Back Ox Tools. I'm Tom. We're straightening these spokes of the handwheel today. Doing a little fitting work here to get them lined up with the milled grooves to do the welding assembly of the handwheel. I'll bring you guys in closer and we'll show you some of this stuff. But this is the 48-inch etching press handwheel. So I'm using this to check this width to make sure that that I've reduced it far enough so that it fits the slots. And this one feels okay. So what I'm doing here is this is where the spokes kind of come together, so I'm just doing a little weld prep. Oop, I already did that one. Doing a little weld prep on that area so I can weld and then grind it flush. Alright, we're going to do a test fitting here. See how things fit. I've been checking as I've been going along, but this will be a full clamping. All right. All right. It's like a steel jigsaw puzzle. Yeah, this is why you need a fixture, because everything's kind of loosey-goosey, right? There's a lot of degrees of freedom here. So you need to lock a few down to help yourself, you know. All right, that's looking pretty good. Let's this on there. This will kind of pull it down. Okay, so I got a lot of grinding to do on these. I just wanted to see how it fit, and I'll bring you in closer so you guys can see the rabbet joint here for the spoke to the rim here. Yeah. And then a close-up of that particular joint there. Anyway, so now you see the need for the welding or the assembly fixture. Not really a welding fixture. It's just to get the pieces oriented correctly, because there's so many pieces, and you know, where do you start, right? And so if you make a three-dimensional buck or a template like this to guide your some of the basic geometry of your assembly, then the rest of it becomes pretty easy. So, and we got some weld preps to do here. So, you know, I got bucket loads of grinding to do here. I'm not going to show that on video. That's just pure sleeping pills. We do have a machining job coming up here. There's the drive hub that fits in here. If you guys remember, this is just a temporary one for welding. So what I'll do is, you know, once I finish the grinding that I want to do with the pieces loose, then what I'll do is put it back in here and get it all tacked together. I will show that because there'll probably be some minor straightening and some things of interest in that. We'll get all this tacked up here, and then we'll remove this and we'll put the real McCoy in there. The steel one that goes in there, but we're going to show some machining on that steel hub. It kind of looks similar to this, but it's got some big flat keys in it and some other stuff. So we'll show that in a little bit. All right, so here's the kind of the close-up of how that joint. So this is I'll just pop it apart a little bit. This is the spoke segment here, and then this is the hand wheel rim, and those fit together like that. And all that'll get welded in and then ground smooth so you can't see it. You know, so it looks. The idea is that it looks like a cast hand wheel. And then here's the center section here, and I was grinding this stuff here. These were interfering with one another a little bit back and forth, so I took a little off of those edges and then put some weld preps on there. So this will all get welded around that and blended in so it looks kind of like one piece. I'll probably put a little, well, I'll fill it up enough so that I can get a little bit of a round in that area right there. So part of the issue is, you know, when you flame cut stuff like this, you can't go to these very narrow gore type points or sharp points. It just melts the stuff away. So you really need, you know, ideally 90-degree corners or you know, greater than 90 or less than 90 or whatever. You know, more obtuse angles. Acute angles are bad. Obtuse angles are good for maintaining shape. So if you have 90-degree corners, you know, like that, or something that's more open, blue Sharpie on metal. Anyway, but you know, you can't have things like that, because the point just gets blown away when you're cutting with almost any process that generates heat anyway. All right, so this is that's the hub we're going to be doing there, and then we have a chunk of cold rolled here, and I think it's 5 inches. Yeah, 5 inches, and this finishes up 4.5 inches in diameter here. So, you know, we got some turning and boring and milling on that puppy there, so we'll get to that. Okay, so we faced one side of this guy here, and I didn't go for 100% cleanup on that. We're going to take some off of the other side here first and get that cleaned up to height, or excuse me, the thickness. And I've taken the backing screws out here so that this thing goes in farther. Like that. Oh. Okay, so here's a reason why you wear gloves. You see that thing right there? That just snagged my glove and actually went through and poked me a little bit. You know, that's just a cut off from the saw. That's the kind of stuff that cuts you when you're doing this work. You know, if you get your necktie in the chuck, that's your own fault. Okay, this is the crap that gives you grief during the day. So I'm sitting up tight against the spider and the chuck, and I'm just knocking it down with my little bopper here to get that cleared out. Gloves are nowhere near rotating parts. That's the way you keep it. You can stay safe with them, but you got to know what you're doing. Okay, that cut's fading out right there, so I'm just going to stop and come out and dig in a little farther. This is 550 RPM and 12 thousandths per rev, I think. Let's see here. So we're on G. G7. Yeah, that's 8 thousandths per rev. Sorry. Alright, so let's just get a quick scale job here. Okay, I got a ways to go. Smoky. Okay, so I flipped it around. Now I'm going to do my little trick where I just turn a little shoulder on that, give me a fresh edge there. And now, take that out. So we're going to flip it around and we're going to hold it by this nice fresh edge now that has a shoulder that I can locate against. And if I did my math right, yeah, it's got just enough to turn that the first shoulder on the part. Now I backed that up. The reason I backed that up because I was going to be swinging like this, and that was right behind me, that the insert there. So okay. Right there. Yeah, not much left. Okay, well, it's okay. Now these are hot chips here. You got to stay out of the way. That's 3 inches, or pretty close anyway. I gotta get some calipers, but we're still oversized 60 thousandths, so I'm gonna finish that shoulder a little bit. Okay, I'm going to let that cool off for a little bit, and we're going to come back in a few minutes and poke a hole through the middle of that. All right, so we're gonna smack a hole through here. It gets a hole that's about 1.75 inches in diameter through that, and so it gets bored. What we're going to do just initially is just smack a hole through it so that we can follow it with a larger drill. And so there's a kind of an optimal size, you know, one that's for a pilot hole. So you want to take you want to use a relatively small drill because it's easy to push, right? But it has to be long enough to get through and sturdy enough so that you can actually push on it. So I find 1/2 inch is a pretty. This is a 1/2 inch drill. You know, this is a 12 millimeter drill. Is about all I care to crank on manually. If you're power feeding, that's different. But this will go through real nice, and it takes that center out. When I go back with a larger drill, it takes the center out, and I'm going to go in there with 1.25 inches or something like that, and it'll just breeze through there because that center section where the cutting velocity is 0 is already gone, and so the lips of the drill farther from the center are doing the cutting on the next size up drill. So we're going to go ahead and pop through with this guy right here. And get up there. Let's see. It's probably okay. Yeah, that'll work. Now I'm not gonna. Okay, so let's talk about that for a split second. So I'm just going to go in with this drill. And this is a jobber length drill here. I'm not going to center drill this. And you go, oh, why is he not center drilling that, right? And well, the reason is that I'm going to bore it. Okay, I'm going to go in there with a boring bar. So who cares if this hole is a little bit crooked? Nobody cares. It's going to be gone. It's going to be chips in the chip pan. So it saves me a tool change and then hunting down a center drill or whatever, right? You don't have to center drill every single hole, in particular if you're going to follow with a boring bar, right? It's a waste of time. It's a waste of your center drill too. So anyway, that's a little soapbox moment there. So. You can see that didn't take too long. I was pushing it pretty hard there, but that's what you do, right? There's one of the chips. It's tan and then going to blue. So that this was what, 500 RPM? Yeah, 510 RPM. So it was right at the it was probably a little fast. But if you pack and use coolant, you can use a slightly higher cutting speed. So now I'm going to switch over and get a larger drill. All right, so we got a big drill here. This is a 1.25 inch drill, and so we got to change speeds here. We need about 300 RPM. Let's do that. Yeah, looks pretty good. Now this is a brand new drill too. I don't think I've used this one yet, so I want to be real careful starting it. Oh, you know what? Well, take a look at something there. Maybe it isn't a brand new drill. It's a brand new flea market drill is what it is. Oh, look at that. Somebody ground that kind of for brass. Alright, well let's see what they did was they put a little flat on it to make that edge not quite so sharp for soft material, well, grabby materials like brass. I guess I didn't notice that when I got it. Let's see if it works here. It may not like steel. I may have to touch it up a little bit, but yeah, the chip. All right, so we're gonna you see that chip? It's striated. It's not cutting. It's kind of shaving it off. That's not what we want for this deal here. So let me get something different. All right. So this is 1 3/16, a little bit smaller, but the edge looks pretty good. Yeah, you see the chips curling there? That's kind of what we want to see. Let's get a boring bar. Alright, so I went in the box and got one of, I call this one, this is a hamburger looking bar here, but I kind of call it Old Faithful. This thing, it never lets me down. Anyway, it'll fit in there easily and reach no problem. It's relieved enough on the side. This uses a triangular insert here, and you can see this thing's been through the wars. And I'll get it in a holder here and get her on center and have at it. Yeah, this particular one I've had for a long time, and we need 2 inches through. All right. So what I'm doing here, guys, is let's see, can you see that? Let's see what you can see here. You know, let's turn it this way here, so we can kind of see for a sec. Let me run this way a little. Yeah, it's better. So what I'm doing is I'm just measuring from the holder to the tool tip there, right? And basically, I really don't want, you know, you don't want it just what you need. You want a little more. So I'm just going to set it at, say, 2 5/16 there. Oop, there goes my scale. And that'll give me, you know, the shortest overhang. I got to get my scale around. I won't be able to think about anything else, so. Crap, where'd it go? There it is. Okay, that wasn't too bad. If I don't have that in my pocket, I can't even think right, okay? So, alright, so we're going to be wanking on this a little bit, so I'm just going to put a little extra reef on it there. center height. Alright, that looks pretty good. So I know the number from the ways off of that bar, or excuse me, off the carriage off of that bar to the machine center line. So, okay, so let's see here. Right there, it's going to touch off. Go through, right about there. Okay. All right, that looks pretty good. And this one we're going to run. We'll run it at the 500 RPM. And we'll try the 15 thousandths per rev feed. We'll try that initially. With some lighter cuts and see how that behaves. That's 0.4 millimeter per rev for our metric viewers. Let me roll this in a little closer here so you can see what's going on. All right. That was just a kind of a skim pass to make sure there was no kind of high spots in there. It seemed to be behaving itself. Chips are breaking. Okay. So, kind of the general rule is you don't care about what your roughing looks like. In fact, rough ugly is a real good rule. You just want to get that material out of your way, and it doesn't really matter what it looks like. If your chips are breaking properly and the setup's behaving itself, don't mess with it. And don't overshoot. So you get excited when you're roughing and it's going well, but it's easy enough to overshoot and have a problem. But so we're 1.25 inches now, something like that. All right, let's take a couple passes. So much for the 15 thousandths feet. I think I chipped the insert there. I'm going to get a new corner on it. So I switched the insert over and I reduced the feed rate to about 8 thousandths per rev, which is, I don't know, 0.2 millimeter per rev, something like that. Anyway, it's cooperating a little bit better. Okay, so what I'm gonna do, this thing, it's making these kind of longer, stringier chips, which are not ideal, but it's cutting pretty good. What I want to do is kind of clean out right underneath the chuck a little bit, because what'll happen is one of those longer chips will snag the stuff that's in your chip pan, and it'll basically kind of mechanically vacuum your chip pan for you and wad it all up around around the chuck. So it's not a cool deal. It's kind of scares the crap out of you, actually. So. Alright, so we got about a 1/16 to go here. And let's see, do I want to switch bars? Nah, I don't think so. Let's take a couple of lighter passes there. I think I'm going to get a new one. Alright, still got about 30 thou here. Alright, so the question is, do we want to finish that, flip it around and do the bore? And I think I want to finish this side and finish the bore. So I slowed the feed rate down even more for these last couple of cuts, so I get a nice finish. All right, let's all right, 1" 740. So we want to start taking accurate measurements now. But what I'm going to do is I'm going to leave that bore alone for a little bit. And the reason is I haven't finished this stuff here. So I got more to come off of here. And now this is a pretty heavy steel part, but when you have a lot of roughing to do and maybe a thinner aspect ratio, the bore affects the OD and the OD affects the bore. So you really kind of have to bring those in kind of together if you're working to tight tolerances. Now this isn't particularly tight, you know. The bore I want good because it gets a bronze bushing pressed in it, so I want that to be pretty good. This OD gets welded in the hand wheel, so it's not a big deal. This OD is not a big deal, so the bore is really what's important. So what I want to do is bring this down to my 3 inches and then come back in here and take out that last 10 thousandths out of the out of that ID. and make sure it's nice and cool and all that. So let's switch over here. And the other thing I want to do is get my shoulder length correct. Those are bad chips right there. Those will cut your arm off right there. Those suckers. All right, let's see where I am. All right, so I got about 20,000 somewhere in there. Half a millimeter left. And let me get a better measuring tool here. Okay, 16 thousandths. Two thousandths over. Yeah. 3.002. That's fine for what we're doing. And then it's not too hot. Alright, so we got 10 thousandths on the ID to deal with. I'm just getting a pickup here again. Alright, I'm going to take about 3 thousandths there, something like that. I got 5 thousandths left. 5.5 thousandths. Okay. Oop. Wrong direction there, Mr. Wizard. one thing I've been thinking about is, you know, this thing gets welded into that hand wheel, and the welding is really probably going to affect this bore more than anything. Bronze bushings are pretty forgiving on press fits, but the welding will probably affect. Yeah, I think I'm going to leave it a little small actually. Then I can flap wheel it out or something like that to after it's done welded. Well, I don't know. We got 1.5. I don't know. What should we do? Take it out? 1.5. Yeah. One more. So the first thing I check for is to see if the spring pass will take a little bit, and it's got a little there. So, ooh, you know what? That didn't look good. That looked like too much to me. That looked like too much. See if we can get onto that little. The size of the chip alarmed me there on that spring pad. Yeah, good thing. 755. Yeah. All right. You know what? We're leaving it. That'll get eaten up in a chamfer. Calling it good. It's too hard to pick up a 1.5 bore, you know. Just gonna break that. That's probably gonna get rounded off a little differently later on. I must have bumped it. Doesn't look like it didn't look like I bumped the dial, but something moved. All right. So this is where you think for 2 seconds and go, do I need to do anything else while I got it like this? Should probably radius that. All right, so I flipped it around and indicated it in, and now I want to get the thickness where I want it. I was going to do the thickness earlier, and I think I said that in the video, but I didn't because I wanted more to hang on to. So I got about 66 thousandths left, 1.5 millimeters, something like that. And actually, a couple of things to note here. I was thinking about that while I was cutting. So when you flip a blank around like that, it doesn't automatically even though you got a nice freshly turned surface, it doesn't necessarily orient itself well, and that's what happened with this one. I had to clock it around a little bit and run the indicator on a surface that was turned in the other setup to true it up. Anyway, so I got it within 1.5 thou just by clocking it a few times and trying it. The other thing is I've left some space behind here. I haven't shoved it all the way up in there so I can get the calipers in for one. Okay, I got 31 thousandths left. And the other thing is between the chuck jaw and this back face here, and the chuck jaw here. I don't want that right up against there, because I have to turn this OD all the way off, and that ring will go with it. So I've left a 1/16 or so behind there, so when I turn that off, I got a place to go there, and I can turn it all the way off and not bump into my chuck jaws. So it's just, you know, it's little stuff like that that I'm trying to point out when I think of it anyway. So it's one more here. Yeah, 5/1000. That's it. Actually, just gonna take it on the way out. What I want to do, I got this little ring on here. I want to get rid of that ring first and get it off of there. Okay, so that's just what I wanted to happen here, is this ring. That's the ring. The chip will never break on something like that, and so if you can thin it so that you can break it later on, that's the way to handle it. So, all right, so let's get a, you know what, I need some bigger measuring tools here. These little calipers won't make it here. Let's see what we got here. Just scale. Okay, so yeah, we'll take a measurement. Inch, what? 750. Oh, we got. Oh, see, that's what happens. I read the scale, right, and I was just looking at that, and I go, "Hey, I'm pretty close to 4.5." Well, I was pretty close to 4 3/4. Well, when I checked it with a micrometer, then it's like way the hell off. Oh well. And I believe, I better get the drawing. And then this one here, I'll pull it out a little bit and do that one. Anyway, that's about it on that. And then we go over to the mill and we're going to cut some big keyways like that, some holes, and then a bolt pattern around the outside. Okay, so I don't know about you guys, I'm tired. We got this thing ready for the mill now. OD, bore, step. So this is the hub for the hand wheel. Next episode we'll go over to the mill and we'll cut these keyways and put the bolt pattern in there and all that. And then we'll start tacking that hand wheel up and see what happens, see how it moves around, see what we got to do to correct for it, and get that thing put together. So I hope you liked it. Stay tuned. There'll be a lot of episodes related to related to this etching press. It's going to take, I don't know, the better part of a year to build the whole thing. So it's a lot of videos and it's a lot of work and a lot of steel. It's all steel, or mostly steel. There's some bronze and some other materials in there, but the bulk of it's steel. So steel is real. Just remember that. So talk to you later.